The image on the top left shows a typical layout of an accelerometer. A piezoelectric crystal is sandwiched between a mass and the base. As the crystal moves on the machine bearing up and down, the crystal is squeezed between the mass and the base. A small amount of electricity is emitted from the crystal proportional to the mechanical force applied. This current is then amplified and transmitted by the cable to the vibration tester. On the lower left, we can see that there's 3 accelerometers in the triaxial sensor. On the lower right, we see that each accelerometer measures vibration in one of the 3 directions of shaft movement. Several options exist for mounting sensors. The method and quality of the mounting directly impacts the signal accuracy. See the graph on the top. The A10 comes with a triaxial sensor, measuring 3 axes simultaneously. Stud mounting is for permanently mounted applications. Adhesive mount is for portable measurements where higher frequency response is needed, and a magnet mount is the most common method in portable vibration measurement. Make sure that you roll the sensor when using a magnet mount to prevent damage to the crystal. Use the quick reference guide. Here you can see that we've selected our location to take measurement. Mount the sensor on the top, side, or end. The triaxial sensor is aligned at 90 degrees, so try to mount your sensor top, side, or end. Attach the sensor to clean, bare, flat metal. Take a rag to wipe away dirt, grease, and grime. Hold the sensor firmly and carefully roll the sensor onto the surface to minimize impact. Notice there's 2 legs of the magnet. Turn the magnet to align the legs to the curved surface if needed. Here we see 2 images. The image on the left shows the inside of the machine, and the image on the right, we've superimposed the bearings and the coupling onto the image. Visualize the shaft and the bearings inside the machine. Mount the sensor on the bearing housing of the motor and the pump. The cutaway drawing on the top right, we can see 2 pump bearings are right next to each other. Why measure from bearings that are only inches apart? We're going to get the exact same data. So if the motor and pump is small, we would see the same data from both bearings on the motor and both bearings on the pump. If the motor is large, greater than 30 inches between bearings, we need to measure both bearings on the motor to make sure we don't miss a fault. If we know the machine is small, you don't need to measure from all 4 bearings. You can just skip one of the motor bearings and skip one of the pump bearings. The diagnostic engine will use the data available to make its diagnosis. At the bottom, you'll see some bad locations for mounting a sensor. The one on the left, don't mount the sensor on the thin cooling fan cover. The second one over, don't mount it on the motor fins. The third one from the left, don't mount it on the coupling guard. And over on the right, don't mount it on the pump impeller or the piping or the foundation. Here's another example showing that we don't need to measure all bearings on a machine. So here we see 2 bearing locations, location 3 and location 4. If we take measurements at bearing number 3, we're going to get vibration from 2 bearings. If we take measurements from location number 4, we're going to get vibration from 4 bearings. If any of the bearings are bad, we'll overhaul the compressor. So notice that we'll get multiple vibrations from 4 different bearings from one location.